Hi folks, here we are at the board. We're going to simplify some radicals, okay? So, when you are simplifying radicals, you got to look for perfect squares. Perfect squares are things that you can square root and it comes out to a nice whole number. Like 2 squared is 4, right? 2 times 2, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. This goes on forever. These are perfect squares. Again, these are what we're looking for. So when we're simplifying the square root of 75, we're not going to say 8.3 blah, 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 blah. That'll go on forever. We're looking for one of these perfect squares that goes into 75. And you might think, oh, well, 25 goes in there. That's a good guess. And it does. So 75 is 25 times 3. So we're going to put those both in radicals like that. You could put the multiplication in between them. You could honestly just mush them right next to each other. It doesn't matter. You take the square root of the perfect square. Square root of 25 is 5. And then 5 times the square root of 3 is just written as 5 root 3. That's it. That's your final answer. Okay, not too bad, Mr. Plate. Okay, all right. So we look at 18, and you're like, well, which perfect square goes into 18? 4 doesn't go in there, but 9 does. It's 9 times 2. That's pretty light. Yeah, that might be a problem. I won't use that green anymore. Square root of 9 is 3, so we have 3 root 2. Always check, make sure there are no more perfect squares left in that radical. And 2 doesn't have any yet. You could say 1 is a perfect square, but square root of 1 is 1, so you don't really get anywhere with that. All right, 108. Now, there is a large square root that goes into this, but let's say we didn't know that, and we were just trying stuff out, and we were like, 4. Does 4 go into 108? And you're like, yeah, it does. It's 4 times 27. So you're like, oh, square root of 4 times the square root of 27. The square root of 4 is 2, obviously. So we have 2 root 27. But 27, you might not be able to see it with the glare there. 27 still has a perfect square in it, and it's 9, right? So we could break that up even further. Oh boy, it's 9 times 3. I'm going to trade marker color there. Oh yeah, you can't even see that. Let me just rewrite that real quick. 2 root 27. And we made 27 9 times 3. There we go. So the square root of 9 is 3, but we also have this 2 out there, so we're going to have to multiply those together. So 2 times 3 is 6, so it becomes 6 root 3. That would be our final answer, because there are no more perfect squares left in 3. Do you know what I mean? Now, from the get-go, you might have been able to recognize that like 36 goes into 108. So you could say that's 36 times 3. And then the square root of 36 is 6, so you get 6 root 3 that way. So you get the same answer, but if you can figure out the larger square root first, it'll save you a little bit of work. All right, look at D, square root of 64. 64 is a perfect square. What's the square root of 64? 8. So that's it. Easy peasy, eh? Now let me scooch a little closer here, because I'm getting a wicked glare on there. Now I want you guys to see this. Now this is a problem. You can never have a square root in the denominator, but we can change any fraction however we want. But whatever you do to the denominator, you also have to do to the numerator when you're changing a fraction. So what we can do is we can multiply it by itself to turn it into a perfect square. But if we do that on the bottom, we have to do it on the top. And let me show you how that works. Square root of 2 times the square root of 2 would be the square root of 4, and the square root of 4 is 2. But I like to think of this as a shortcut. If I had the square root of 8 times the square root of 8, I would get the square root of 64, which is 8. So if you ever multiply a square root times itself, the square root symbols just go away. Square root of 8 times the square root of 8 is 8. Square root of 31 times the square root of 31 will just end up being 31. square root of smiley face times the square root of smiley face. You guessed it, smiley face. So you can save yourself a step of writing there if you remember that. But on top we have the square root of 7 times the square root of 2 is the square root of 14. Now there are no perfect squares in 14 except for 1. But you never need to say, isn't 1 a perfect square? No, we're not counting that, okay? So it just becomes the square root of 14 over 2. You can't simplify radicals with regular integers like that, so that would be your final answer. Look at F. I gotta make a little room here with my 6 root 3 stuff. Root 18 over 6. Now, it is fine if you have a radical in the numerator. That's all good, baby. It's all gravy. Come on now. But there are perfect squares in 18. As you see from example B up here, 9 goes into it. So if we simplify that, 18 is 9 times 2. Square root of 9 is 3. So the numerator would simplify to 3 root 2. Denominator is 6. Again, you don't have to worry about the denominator here because there is no radical. But remember we said you always need to look for, make sure there are no more perfect squares. And here's the other thing you got to look for. See if you can simplify the big boy numbers. So this 3 and 6, they're both outside the radical. If you had the fraction 3/6, you would make it 1/2, right? Same thing here. 3 goes into 3 one time, 3 goes into 6 2 times. So it really becomes 1 root 2, which we just write as root 2, over 2. Make sure your marker is nice and squeaky, okay? It's very important. All right, what up, G? What up, G? Root 90 over 3. Fantastic. No radical in the denominator, no perfect square. Oh, 90. We know, oh, Mr. Plant, we know that's 9 times 10, and I know that 9 is a perfect square. The square root of 9 is 3, so we'd have 3 root 10 over 3. And then you're like, oh, well, we got to check about the big numbers outside the radicals. Duh. 3 and 3. 3 goes into 3 one time, and 3 goes into 3 one time. So it becomes 1 root 10 over 1, which is just root 10. And there are no more perfect squares in 10. So that would be our final answer. Now, I'm going to have to climb over the desk here in a minute. I'm just kidding. I'm just being silly, guys. Root 3 over root 3. If I had the fraction 7 over 7, it'd be 1, right? When you have the same thing in the numerator and the denominator, it just comes out to 1. Sweet. We've simplified some radicals. Let's solve some equations. How's that sound?